On your feet. Dynamite. Boom, boom, boom. Oh, wap, blah, ba, blah, boom, boom, boom. Oh, wap, blah, ba, blah, boom, boom, boom. Baby, what you doing to me? The whole world's feeling like a ride at the fair. Rocking and a reeling and I'm up in the air. I'm blowing the lid right off of the box. You're melting my heart, you're knocking my socks. Boom, boom, boom. Oh, wap, blah, ba, blah, boom, boom, boom. Oh, wap, blah, ba, blah, boom, boom, boom. Baby, what you doing to me? Agitated. A detonated.
Where did you get that?
On your feet.
We mostly focused on Project 1, and we had to make a coil gun and make a video of us making it, shooting it, writing up about it, working with the group for the technical document. We also had week 3 stuff where we watched a lot of live scribe videos about force fields, magnetism, semiconductors, and circuits. We also had to do a quiz about the coil gun and make sure that we really knew what we were doing. I learned the answers to the equations from last week, which is good because I really wanted to know if I was doing them right or not. And I got them wrong because I had the wrong radius that I found somewhere. But once I put it in, I was able to figure it out. And I learned more about how the coil gun circuits worked. I had a basic idea, but now I'm more clear on it. I learned about magnetism, which I found interesting because I'd never really studied about magnets before. Okay, so I've taped this onto here, so the barrel onto here, and now thanks to Kodak, we have a free battery that came in the camera. So I'm going to place the battery in the place, and then underneath, that little thing that this underneath part, I'm going to hold that button down right here. I'm going to hold it until it charges, and you'll hear a little whir, and you will see the light come on. So let's put this in. Like that. I'm going to push that. There it goes. Writing. Oh, charged. Now I'm going to let go. And I'm going to put the BB in the chute. And drop it down like that. And then I'm going to face it at this goldfish box over here. And I'm going to push the trigger. And there it goes. Coil gun. this week we focused on light, frequencies, electromagnetic rays, and waves, and we had to do an Excel worksheet, and we had to fill out we had to fill out about it, and it was kind of difficult to find all the information. And we also did some reading from a physics classroom on reflection and refraction, and I should have been working more on Project 2, but I didn't do as much on that. And we also did the Project 1 peer evaluation. What I learned was that I know nothing about light, and didn't know there were so many different categories about it, and how there's different frequencies and energy levels. I like the category of coolest man-made inventions. I had no idea how some of these things worked, and now I do. And I learned that light is predictable and follows the law of reflection, where the incident ray approaches the mirror and then bounces off at an angle as the reflection ray. And I learned that refraction is where the light changes angles as it goes through a certain media. Alright, for this week, which was week 5, we had to work on our different things, like the controversial debates we had to go look on, and these different things. So we had to do the simulations over here, and we did all 3 of them, and we took some screenshots on it. We looked at the optics workbench, which was pretty cool, and that helped me understand how the telescope and different optics work. And we watched these 2 light scribes. The main focus, at least for me this week, was working on Project 2, which was our telescope. So for our telescope, for my part, me and Kyle both worked on the telescope, and John and Tim worked on building a microscope for it. And then we were able to post it to YouTube. And so here's my video
We are going to just
of
take
myself making
this
it.
thing,
And from there, I was able to put it on my Google site under Project 2. And here's my Project 2. So it should be there. I'll have to double check why it's not there. I thought I had embedded it in there already. But the PowerPoint's linked, so that's good. And so that's good. And then what I learned this week is I learned all about optics and telescopes, like this one here, and how when you take your optics lens and the objective lens takes in the light and it goes to the focal point, and from the focal point, and then the eyepiece takes the focal point and magnifies it so you can see it. And I also learned about infrared rays and the different types of rays. And here's more pictures of my telescope. It's kind of sloppy with the tape job. I'll have to fix that. And there's another one right here. So there's both the pieces. Alright, for Project 2 we're making a telescope. These are the pieces that we need. We have 2 cardboard pipes that are going to fit into each other like this. We have the eyepiece right here, and we have the objective lens and some tape. So these are the pieces that we're going to use, and we'll go from there. This is going to hook on one end. I'm going to tape it to one end, while this piece goes on the other, just like this. Here is the objective lens, which brings in light and there's a focus point. And with the eyepiece, it magnifies the light that the objective lens brings in and makes it into a viewable image. And now you just adjust it, and it works.
Where did you get I'm here at Deer Valley Airport at the Phoenix Police Air Unit. I'm here with Officer Jim Linehan. Going to be interviewing him today. We're here to discuss the applications of thermograph technology. And the Phoenix Police Department has these equipped on their air units. We actually have these infrared video cameras right here. So I'm going to ask Jim a few questions. Jim, what does the FLAIR unit stand for?
FLAIR stands for forward-looking infrared.
And can you briefly describe what it does?
Basically, it's a sensor, and it senses the differences between temperatures on persons, the ground, vehicles, and it's not even really a camera, it's actually a sensor.
So it picks up like the heat radiation off of those objects, and it displays that on the video camera in the board. And how many aircraft does Phoenix have with that unit?
We have 5 airframes like this with it on. We have 3 koalas with it on it. We also have some airplanes.
Yeah. Does it get used pretty often?
Almost every night.
Every night, yeah. And over a spotlight, why would you use the FLAIR when you're searching for somebody on the ground? What makes it more optional?
Well, there's a couple reasons. One, if we're looking at a suspect under FLAIR, we're looking at it, they don't know we're looking at it. With the searchlight on, when they see that searchlight, they know they're being looked at, and they will hunker down or hide in a tree or bush.
Yeah.
With the FLAIR system, they have no idea they're being looked at. A lot of times we'll be able to pick up guys under boats, under cars, in trees and in bushes. We can see them with the FLAIR, but we wouldn't be able to see them with the searchlight.
Yeah, so a lot more uses for it. And then, with that being known, can you use it during the day?
Yes, we'll prefer to use it during the day because our visual acuity during the daytime is much better.
Right, objects don't stand out as much. And so, with that note, do you have any significant memories using the FLAIR that you find a few people using it?
Well, about 2 months ago, I was flying and my partner was looking for some guys. They bailed out of kind of a stash house for illegals, and about 20 of them went running. And the last recollection of the officers was that 4 went toward this field. It was a really, really, really big field. Lots of rows of vegetation. And my partner was just scanning around. He saw 3 significant resources, and 2 suspects were curled up in a ball next to each other. So we got those 2 guys and we directed officers into it. We got all 4 of them hiding in the field in different locations.
Very cool, very cool. Well, we're going to go ahead and take a look at the unit itself and go from there. So here we are looking at the camera that the officer gets to use for his visual display. Right now we're looking at a regular video camera he has. What kind of zoom does this have on it, Jim?
You know, I don't really know the numbers. You can set it up for an incremental zoom, or you can do it where it does a consistent zoom in and out, as you can see. I don't remember what the actual ratio is.
Alright, and we're looking out at the airport here now, so you get good clarity and over long distances.
I'm trying to stop the drift right now. There's a setting on it to stop the drift. So there. Cool. Alright, let me switch over to FLAIR. Okay, now we're in infrared.
And this is in infrared right now.
And you can tell, you can actually read the difference in temperatures between the paint where it says Phoenix Police on the helicopter outside.
Right, the heat coming off of it.
And there are several adjustments to make it better. This is almost like it's called level and gain, but it's actually, it's like a brightness and contrast, but in FLAIR terminology it's called level and gain. You adjust those to get the best picture quality.
It looks good. And then we'll go ahead and look at the camera itself while it's being used. This is the camera here. He's looking through that lens, and there's actually a cooling unit in this bulb so that the sensor itself can see the heat reflected off objects. And there we go. So
I want to find a person for you to look at it here too, so that'll make it kind of this one here. Let's see, where is somebody? Guess I have to go to these 2 guys over here.
we We're gonna see what these guys
That
lift.
cart might be in the way. One of you wants to move that cart.
Katie, can you move that cart?
There's Katie right there.
Oh.
I lost her.
Here's these guys working on some doors over here.
There's the cart. And there's the cart.
Oh, there's the guys. Ah, look at that. That's cool.
See the guy wearing sunglasses.
Yeah. Looks like a video game.
And then there's an actual focus. So you can make it a sharper picture.
Ah, that's great.
You can see the hair on the side of everything.
Or the lack of. All right. Well, Jim, thank you for this introductory to the flare unit here at